intersection of three planes in a point. Consider the matrix B, which represents the solution to the system of planes shown in matrix A. Explain the solution. So basically, this matrix represents a system, which system of planes. So there are three planes involved, right? And these are their normals, correct? Coefficients, okay, or the normal values rather, right? And that is a constant value which is on equal to sign, right side of equal to. Now when you do row reduction process, then that is what you got. So B represents the solution for the system. Now what does that represent? So when you get a solution like this, then you can do backward calculation, right? And then figure out what the solution is, right? It very clearly indicates that the intersection or the solution is a point, correct? Is a point, right? So from here, these are x, y, and z. Whenever you see this, just a reminder for you, this is x, y, and z coefficients, right, of the three different planes, right? And this is equal to, and that is on the right side of equal to. This is left side of equal to, correct? So we can translate it back to the equation, right? So this says this is z value, coefficient of z. So we'll write this as minus 2z equals to 0. Do you see that? That is how you're going to translate it. And here we have 5y, okay? This is 5y plus 20z equals to 5. And here we say minus x plus y plus 5z equals to 0. So the solution translates back to these equations. These are my final equations from where we can figure out what the answer is, correct? Now from here we can say what is z equals to, right? So if this implies, so from here we'll plug in the values and see our solution, correct? So from here we can say z is equal to 0, correct? So this implies z equals to 0. 0 divided by minus 2. Now if I plug in z equals to 0 here, I get 5y plus 0 equals to 5, and then y equals to 5 divided by 5. So I get y equals to 1, right? Now I got z as 0 and y as 1, so I can plug it here. So when I put z as 0, this becomes 0. When I put y as 1, it becomes 1. So minus x plus 1 is 0, or x is equal to 1. So I get x equals to 1. So that is the solution. Do you understand? Explain the solution. So our solution to this problem here is a point. So these planes intersect at a point, and the point, let me call this point as P, and the value of point is 1. The coordinates of the point is 1, 1, and 0, correct? So the x equals to 1, y equals to 1, and z equals to 1 is the set of points on this coordinates, right? So that is how these planes intersect, and that clearly indicates that the solution is just a point, right? To graphically represent it, what we can do is that we can like kind of make it just to show you one. So let's say this is one plane here, right? This is one plane, and then we have another plane which is, let's say, kind of like this. Okay, then these two planes actually intersect like this, correct? But there is a third plane, and third plane is kind of going here inside, right? So basically it's like this. Think it's like getting into this, right? So it's just like, so they intersect at a point here, kind of think like this. So that is how the plane intersect, and that's the point of intersection of the plane with this these two planes, correct? So that's the point of intersection. So that's how it is, and this solution indicates that the system has only one solution, and that is a point P, which is 1, 1 and 0. Thank you.